Good morning. I'm Bob Leffers, and welcome to episode 10 of How to Make Your Own Video Game, Missile Command. Today, we're going to actually build an object in Python that's what we're going to be calling a targeted object, which has the ability to pick a point, a starting point. So we have a starting tuple, some x, y coordinate on the canvas. And what we're going to do is we're going to then go to an end point. We're going to go to the target, so that's where we want to end. So we're going to start here and end there, but we're not going to jump like we did earlier. We're actually going to walk. And so what's going to happen is we're going to walk along a path between the start and the target. And we're going to do that by defining sort of an end. So we're going to have start and end. You could think of this as the current position. And then we'll move the end from start to target. And we're going to move by a distance I'm calling d step or ds. So we're going to move a distance ds. So we've got a start, we've got a target, we've got an end, all tuples. X, Y coordinates on the canvas. And we need to figure out how to move from XS, YS to XE, YE with a distance DS. And we're going to do that by noticing that we just have to increase XS by a small delta X and increase YS by a small delta Y to get to the new point. So what we need to know is what is DY and what is DX given the target point, the starting point, and the distance we want to move. And we're going to do that by noticing that there's two triangles here. One with the little dx's for the small blue triangle, and then there's one with a large dy dx, which is the difference in the vertical and horizontal. And dy is simply the difference between the target y coordinate and the starting y coordinate. And dx is just the difference between the target x coordinate and the starting x coordinate. So what do we know? Well, we've got two triangles that share an angle. So those are called congruent triangles. And the rule on a congruent triangle is that if you take dy and divide by dx of the large triangle, capital dy, capital dx, you'll get the same answer as little dy divided by little dx. And so we can write that as an expression. So the delta y change divided by the delta x change of the big triangle has got to be equal to the delta y change and the delta x change of the little triangle, the little d's. So if we take this expression and we multiply both sides by dx, so you're allowed to do anything in an equation as long as you do it on both sides so it stays equal. So I multiply both sides by dx, didn't change the equation, but then I can divide dx divided by dx is 1, so those go away and I just get dy. So now I have an equation for dy given dx and dy and little dx and big dy and big dx. Now, it turns out I want an equation for dy squared, so I can square both sides, and I get dy squared is little dx squared times big dy squared over big dx squared. Now, the other thing that we know is that the hypotenuse of a triangle, so the ds distance, the hypotenuse of a triangle, is hypotenuse squared is equal to the sum of the squares of the other two sides of the triangle. So ds squared is equal to dx squared plus dy squared. Okay? Now, if dx were 0, then of course ds and dy are the same. And that's how that whole thing works. Here's the dy squared, and there's the dy squared, which means I can replace this dy squared with the contents of the expression on the left. So I'll do that here. And now notice that both terms of this sum have a dx squared, so I can pull it out and put a dx squared outside. So if I multiply it through, I get a dx here and I get a dx there, and I'm back to the original equation. Well, now I can divide both sides by the same number, which is this expression, 1 plus dy squared over dx squared. And these on the right will cancel, and I end up with just the one on the left. And so I have an equation now for dx squared. Now I can simplify this expression a little bit by multiplying by 1, where 1 is dx squared divided by dx squared. And so what happens is when I take this dx squared and I multiply it into this parentheses, I get a dx squared in the front, and this dx squared and this dx squared cancel. And so I end up with this equation, which is a little simpler, right? So I'm looking for dx. So now what I'm going to do is I'm going to take the square root of both sides of that equation. And what I get is that little dx, the distance I have to move, is the big dx times, which is the distance between the starting point and the target, times the distance I want to go, divided by the square root of big dx squared plus big dy squared. So that's pretty good. So I have given the dx and dy's, big dx and big dy's, I calculate from the starting points. I can calculate what dx should be. And then I go back to my equation for the hypotenuse, and I can subtract dx squared from both sides. And then dx squared minus dx squared, of course, is 0. And so I just get dy squared. And then I can take the square root. And so I know that dy is the square root of ds squared minus dx squared. But when you take the square root, you don't know if it should be plus or minus. What we're going to do is we're going to use a function in Python that allows me to copy the sign from big dy and apply it to the square root of ds squared minus dx squared. Here, the sign of dx sets the sign of dx over here. So that's works great. If I'm going, if dx is to the right or to the left, depends on whether big dx is. And so here I can copy the sign of dy and apply it here. And so now I have an expression for dx and for dy. So my inputs are the differences between the starting and target points, right? So those are defined here, the difference between the target and starting points. And then I calculate what dx and dy are, and then I can just move by dx and dy every time I want to move until I get to the end. So let's take a look at the end. So what we want to avoid is if I'm at some end point, so I'm in the middle of this wire, I'm at this point here, and here's the target point I'm headed to. It's possible that the ds is larger than the distance I need to go. And so what I need to do is, before I move and do this calculation using these formulas, because this will go right past x, t, y, t, is that I need to say if the distance I want to move is greater than the distance between my end and my target. And this is a math function that just does the square root for you, that takes the distance. So if ds is greater than the distance between the end and the target, then I just want to say that the end is equal to the target. I want to stop here. So with those conditions, we're ready to go to start putting this in and coding up an object that you give it a starting point and a target. It starts with the end at the start. And then every time you want to move the object, it's going to calculate a new point using the dy and dx that we've just calculated. So let's go ahead and start putting that into Python. Okay. So let's go ahead and start creating our targeted object. We're going to do that by not doing it in Frog Up, but in our library. So we've got our little library here. We're going to add it as a library because we're going to use it for a bunch of things. So the first thing we do is to define an object, you have to create a class. And this class is going to be called target object. And that's all we need to put in there. Now here I could put global variables for the target object, but we don't have any at the moment. We'll deal with those later. So what we're going to do is we're going to define a function that we're going to use to initiate or create the object itself. Okay, so it's underscore underscore init underscore underscore. And the first argument is always itself, right? That's how it's going to work. The object's going to work. It's going to pass the memory element where all the data is going to be. And we can add other properties in here, other parameters. So we want to have a starting point. We want to have a target point. Those are going to be tuples, so where we start, where we want to end. We're going to give it a list of objects that we want to move on the canvas. That'll be an array. And then we want to define the distance that we want to move, and we can default it to a value. So I'm going to default it to 30. That way, if you don't specify it, you get 30. We want to know the delay that we want to wait. This is in milliseconds, so I'm going to put in, let's say, 40 milliseconds for the default. And once we create the object, I'm going to add a auto start equals true. So when we create an object, it will automatically start moving. We can also set it so it doesn't. And then what we need to do is we need to define the memory locations underneath this variable self, which is going to be where it's pointing at the object. And so we're going to say self dot start is going to equal start. Okay, that makes sense. So we're going to store what was given in the argument we called it. We're going to store that in the word start. We're going to self dot target is going to equal target. We're going to say self dot end because we need a current position, and it's going to start with self. So the end is going to start with self dot start. So we're going to have a starting point, a target point, and then the ending point is where we're currently at. So we're going to move end from start to end, like we did in the graphics. Okay. We're going to have the self dot objects is going to be objects. We're going to say self dot, I'm going to say milliseconds for the delay is going to equal delay. Self dot distance, distance is going to be equal to distance. And I also need to keep track of any pending move. So what we're going to do, like we did before, is we're going to do an after. And so we want to have the way to kill that in case we want to delete the object later. We'll talk about that later. And then basically what I'm going to say is, look, if auto start equals true, then I want to do a self dot move. So basically, this creates the object from the arguments passed to it. So when we create a new targeted object, it's going to call this initialize function the constructor function. And now what we need to define is we need to define our function to calculate a new endpoint. So we're going to call it new end, and it's going to take self, and then we're going to pass it explicitly the start point, the target point, and the distance we want to move. And this is where we're going to calculate using the formulas that we did on the earlier. Dx is equal to target 0, that's the x point, minus start of 0, so that's the difference in x. Dy is going to equal target the second coordinate, start of the second coordinate, and then the little dx is big dx times the distance that's being passed in, this space times the distance, divided by, and then we need the math function, math dot sqrt, math dot square root of the distance squared plus, oh, I made a mistake. This is actually the big D squared, big DX squared, plus plus big DY squared. And then I think that works. I'm going to put some spaces in here just for giggles. So big DX squared plus big DY squared. And then we need to calculate dy is equal to math dot copy sign. This is what we talked about earlier. I want to calculate the delta y parameter. So it's going to be distance squared minus little dx squared, and then this is math dot square root of that. So that I take the square root, I lost the parameter, dist. So dx squared, right? This is distance squared minus dx squared, correct. And then the sign I want to copy is the sign of delta of big dy. and that should get me my dy value. And then what I want to do is return. So when the function is going to give me back, it's going to be start of 0 plus dx and start of 1 plus dx. And that should work. I think that should work. So that's the function that's going to give us the next point after moving from start to target by a certain distance. Now, we may need to define a move function. So we want to be able to have this object move. And so we're going to define move, and it puts self in. We don't need to pass it any parameters. We just want to move. It knows everything else. And we're going to say if self.end is equal to self.target. Okay, so if, as we're moving from start to target, if the ending point where we're at is equal to target, then in that case, we're done. And we want to basically call a function that says we've reached our target. So we're to define a function. What do you want to do when you reach the target? Okay. Now, if self.distance is greater than the math distance between self.end and self.target. So if the distance between the ending point and the target is less than the distance I want to step, okay, then in that case, I want to set self.end simply equal to self.target. In other words, I don't want to step past, right? So if the distance I want to move is past where the ending point is, or the target point is, that I just want to set, hey, don't move the whole distance, just go from where you are to the ending point. Now, I forgot one thing. So if the end is equal to the target and we quit, then we don't actually want to move. We want to bail. We want to return. We want to end the function, right? So we finished moving. We're not going to move anymore. We're going to call another function instead, which is reach target. So here, we're going to set the end of the target, and then after the delay, we'll actually go ahead and call reach target. We want to make sure we get to the target, actually at the target, draw the shapes to the target, and then the next step is where we decide we're done. And if the distance is not greater than the distance we need to move, then we're going to have an else here. So in this case, we want to say that self.end is equal to self.newEnd. So this calls the function that we wrote up above, and so it's going to automatically get the self that automatically passed. And then we're going to give it the starting point, which is actually self.end, and self.target. And then we want to pass it the self.distance that we created up above, right? And so we're going to go from the current ending point, we're going to calculate a new ending point on its way to target by moving that distance. And then, at that point, we need to take the coordinates we just calculated, the ending points, and actually draw ourselves, okay? So we're going to call a function to do that, self.redraw, I'll call it, redraw. So we're going to do self.redraw, and that will redraw the object in the canvas. We'll do that function next. But, and then, once we start moving, we want to keep moving until we get the target. So we're going to do a self.after. We're going to remember the thing that we're starting. We're going to do a canvas after function. So on the canvas, we're going to have the canvas remind me to call after self.milliseconds. So it's going to wait until after self.milliseconds, and then we want to call self.move. And you don't put an argument there. It's not going to call the function. It's going to point at the function. So what this is going to do is it's going to calculate the new ending point, because we start off with the ending point equal the starting point. It's going to calculate a new ending point, and using our function, calculate the new ending point. It's going to then redraw ourselves, right? We're going to be more than one of us, and then wait by delay in milliseconds, and then move again. So now the function that we need to write is define function redraw. We don't need to pass any arguments to have all the information we need in our object. And so objects could be more than one. So the first thing we're going to do is we're going to say, look, for each object in objects, in self.objects. So for each of those objects, we're going to basically check to see how many coordinates the object has. Length of canvas dot chords, can't see for some reason, canvas chords of the object that we've got. If that, I don't need parentheses up here, sorry. So if the length is equal to 2, okay, which is what it's going to be when it's image. An image only has a single set of coordinates, x and y, so a single tuple. So the length of the coordinates is 2. Then we know to update the canvas dot chords of the object to self dot end of 0 and self dot end of 1. So if there's 2 coordinates, then we just need to update. We're moving the endpoint towards target. We just need to update x and y. So we've moved the object that way. Now, otherwise, I'm going to copy this line. So I forget how to do it. Copy, paste, and now it's going to actually be self dot start of 0, self dot start of 1, and then self dot end. So we're going from the starting point to the ending point. That's how we want to redraw a line, for example. And that's pretty much it. That's pretty much what we want to do for redrawing. So we've already set it up so that if it's going to go through a bunch of objects, if, for example, if I have a line and an image, it'll move the image and it'll move the line from start to end. Now we have to define a function that we used up above, which is what happens when I reach the target. So when I reach the target, these are missing parentheses. You see these guys are hanging out here? Canvas chords. Oh, this goes this way. This goes this way. Now these are lined up, right? Now these are lined up. Yep, that works out. Well, canvas coordinates, you give it the object, you give it the 2 points. I give it the object, I give it the 4 points. Those are the 2 types of number. Now, when I reach the target, for right now, let's just pass. That means don't do anything. Okay? We're just not going to do anything. And then we're going to define a delete function that will delete myself because we might want to actually get rid of ourselves. So in this case, for each object in objects, self.objects, that's better. So for each object in my list of objects, okay, I'm going to canvas delete the object. So I'm going to delete the object. And the other thing I'm going to do is I'm going to attempt. This is an attempt thing. I'm going to try to canvas after cancel self.after. So, so remember, And then if it can't, so it's going to try to do that. And if it can't do that, then it's going to do nothing, which is we call it pass. And then I'm going to delete myself. So the delete function, for any object in my list of objects, is going to try to delete the object from the canvas. There might be still a pending move command, because remember up here we're going to set an after, so we want to move. But if, for example, I want to cancel myself while I'm still moving, I have to make sure I cancel that after, so it doesn't come back and call me and find no object to move, right? And then I just need to delete myself. So we cleaned up. We deleted myself, and that's pretty much the target object function that we want to create. And so to test it, we're going to use this trick: if underscore underscore name equals underscore underscore main. So that means if so if the name of the function of the Python program that's running is this program, then we're not using it as a library, we're actually testing. So what I'm going to do here is I'm going to say window equals a new TK function. I'm going to say window geometry. Well, here, what's going to do is we're going to copy this stuff from this guy, right? We're going to copy this stuff. We'll do this, pack the frame, define the canvas. We'll do the background white, expand true. We'll set some colors just so we can have them. Copy. I'm going to put those in my lib down at the bottom here. Paste. So I need to grab all these lines and tap them over. Okay, and I'm going to grab an object. If I look over here in images and sound, there's an object in here called bull, which is actually sort of a bullseye. And I'm going to grab that for right now for testing purposes. So what I do that is I create we call it it's more of a site. Let's do this. Push this in here. We're going to say site, S-I-G-H-T, is this object. And then inside this thing, I'm going to define a click function based on the event. We've done this before, right? I'm going to say X and Y are equal to event. Oops, that's supposed to be equal sign. Event.x, event.y. For right now, I'm going to print X and Y just so we can see what it is, where I'm at. And then I'm going to, my site is equal to, well, actually, let's not call it site. I'm going to call it at. It's going to be where I'm at. Oops, looks like that's a reserved variable. I am is equal to canvas dot create line, create image. It's going to be, I have to tell it where I'm going to create it and then what the target is. So I'm going to say, let's start at 0, 0. And then I'm going to say my image is equal to I am at. Okay, and then I'm going to create a line, canvas, create, and canvas create line, and I want to create the line. Let's again start at 0, 0 for right now. And I'm going to start at 0, 0, and I'm going to stay at 0, 0. Right? So I'm going to create an invisible line at 0, 0. And then I'm going to create myself which is a target object, okay? We're going to tell it where we want it to start. So right now it's going to be 0, 0. We want to tell it where we want to go, which is to X and Y, that where we clicked on the screen. And we want to pass it two objects in this case. I am and line. Oh man, I can't type. And then the only thing I need to do here to get this completed is to say canvas.find less than sign button 1 to my function click. This goes here. This comes off of there. And then main loop. So I've buried all this stuff underneath the if main, so none of this stuff will show up if we use this as a library, but it'll let us test how we're doing. So let's go ahead and see what happens. I'm sure I made some typos. All right, we did have some typos. Okay, we have a problem. Target object has no attribute target. Target object has no attribute target. What did I do wrong? That's target. Oh, look at that. I can't spell, man. Target. That's better. Let's try that one more time and start again. Oh, look at that.
Well, let's see. Oh, check it out. There's a mistake here. Start 0, start 1. That's X and Y, and I put X in both. That's the reason it's moving so far down, is it's not using delta Y, it's using delta X twice. Let's just check and see if we've got anything else in here that doesn't look right. Oops, look at that. There's a red line. That always helps. Self. But check the PyCharms does the red line thing, and then all the red lines are going to be problems. Let's give that a try. So I push this button, and oh, look at that. Look at that. It moves directly to where I clicked. Now it turns out, make this window a little bit bigger. Make this thing a little bigger. I'm going to click down here at the bottom, and we have it printing 722.701. So I'm going to do the following. I'm going to change this to 722 and 701, and this is going to be 722, 701 twice. Copy, paste, and this is going to go here. My starting point is going to be at the bottom. I'll show you what that just did. So let's go ahead and kill this, and we'll restart. Let's make my screen a little bit bigger. So now when I click, it comes up from the bottom. That's starting to look like our video game, right? Pretty sweet. And I can click as many times as I want, and I'm moving both the little circle as well as all the way to where I'm ending. And it's going right, if I click and don't move my mouse, it goes right to where I clicked, exactly where I wanted it to. So that's how we can get a targeted object. That's pretty sweet. Now, we can make one small change and change the way this works. We can go to, when we reach the target, we can just say self.delete. Okay? And if I do that, and I make my thing a little bigger, now when I click, it disappears. But it waits until it gets to where I clicked. If I wait, it gets right to where I clicked, and then it disappears. See, it gets right to where the mouse is. That's pretty sweet. I think that's it for this episode.